Hello, my name is Todd Gooch, and this is my second video in the series Tales of Zephrym Cochran. My first video chronicled the building of a starship by creating a small star, small nuclear reaction out in outer space and containing it within an internally generated electromagnetic gravitational field, capping one end of the cylinder off, and then sending the spaceship unidirectionally approaching velocities around the speed of light. This video is about what you're going to find when you get there. What kind of life are you going to see when you finally get out in outer space, so that you're not surprised. I'm able to predict the life that you're going to see out there. I restructured the periodic table recently. Notice how symmetrical it is. There's a symmetrical argument here about restructuring the table that I don't think that people should miss. It's restructured symmetrically around atoms like carbon, which is the second atom here in this green column. The life on this planet is all based on carbon, and the standard model says it this way, that carbon can either give up or take on its outer shell electrons equally. It has 4 outer shell electrons, and according to the octet rule, there should be 8 in the period, so it either gives up or takes on its outer shell electrons. I have a completely different view of the atom. Gravitational unit theory, unified field theory, atomic view, atomic model, and molecular model look at carbon this way and represent it with vector bonding. I'm the first person to ever theorize vector bonding, which shows the electronic flow through the atom and consequently through the molecule. If you wanted to make methane in the standard model, you would add your hydrogens this way. I noticed that the hydrogens have one bonding site over there in the standard model's view of hydrogen. That's not the case over here with carbon. Let me go ahead and quickly go over the simple definitions with the vector bonding. Arrows that face away from atomic symbols are keys. Arrows that face towards atomic symbols are keyholes. The object here is to fit keys into keyholes to make molecules. My view of hydrogen is quite different than the standard model, and it has 2 bonding sites, key and a keyhole, which makes it very similar to the carbon atom that it's attached to here in this methane molecule. And so consequently, hydrogen fits into the same category as the carbon does, because it has an equal number of keys and keyholes too. So let's talk a little bit about hydrogen and the concept of hydrogen-based life. The hydrogen atom is really more like a bar magnet. And it's my belief that its bonding, when it's nascent, when there's only hydrogen around, it may not be a diatomic gas in the strictest sense of the word. And if it is, it's bonding in some odd ways. But it's my belief that that this is like your standard bar magnet. with the flow going like this. It's very reminiscent of the movie 2001. When the bar magnets, the monoliths go and form a star, I'm thinking that that's exactly what's going on here with the hydrogen atoms. That the hydrogen atoms actually move around and form a star, just like in the movie. And I believe that the star itself is the simplest form of life, and often it's described in terms of a life cycle of a star, as to what its properties are and that type of thing. You know, it's hard to assign an intelligence to it, but not ruling out the concept of a star having a life force, because it's built on an atom that's that's right above carbon in this series. Let's talk a little bit about silicon. I don't want to get too far off base, but I do believe that the stars are alive. They're the simplest form of life. We're the next simplest. We're carbon-based life. Then you get into silicon. Again, silicon has an equal number of keys and keyholes. There's a lot of good evidence to say that there is silicon-based life. We see our computers able to perform artificial intelligence operations. I think that we should be very careful about the concept of just calling a computer, because it's obvious that that there are decision structures which could occur from the fact that it gives up or takes on its outer shell electrons. It has an equal number of keys and keyholes. Any way you want to say it, that this is it's very possible that this could form a living entity. I think it's obvious that it does. Somewhere out there in the universe, there's most likely some naturally occurring silicon-based life forms. And here's another odd prediction. Carbon-based life, we breathe oxygen. Well, right below carbon is silicon. Right below oxygen is sulfur. That's odd. It makes me think that there might be silicon-based life that breathes diatomic sulfur, like we breathe diatomic oxygen. The next element is cobalt. And cobalt is in the fourth period. It's right here. There's 18 elements in that period. I'm not going to bother to try and draw the standard model structure for cobalt, but I can draw mine. And it has an equal number of keys and keyholes also. So cobalt looks like this. I always thought cobalt was blue, but I did some research on cobalt. Cobalt's actually a silvery white metal. The blue is impurities that you find in it, or with it. That surprised me, but nevertheless, you're probably still going to find these blue pigments in naturally occurring cobalt forms elsewhere. So you would kind of expect your cobalt life forms to possibly exhibit the pink blue color change that you find in desiccants. I don't have a whole lot to say about them, about this, except that now you've got quite a few more electron phenomena going on here, and the life form that's based on this is going to be more geometrically. There's going to be more angles to the to what you see. You would expect them to be highly intelligent creatures and made out of metal. Possibly exhibit a blue, pink color change in the presence of water, that type of thing. The next one down is rhodium, which has the same configuration. Also silvery white metal. Probably going to have similar properties to the cobalt, being just differences the same as carbon to silicon-based life. So similar but completely different. And now what I'd like to talk about just briefly is the 6th and 7th period elements. Don't have a lot to say except that we all know that these are the radioactive elements. So you would expect these beings to be radioactive. These two elements that comprise this are ytterbium and nobelium. Excuse me, not nobelium. I can't see it. Yes, definitely nobelium. Ytterbium and nobelium. Pardon me. Ytterbium and nobelium are very far down the table. They have 32 outer shell electrons. They'll have an equal number of keys and keyholes. But what I have to say about them is that they'll be far more intelligent than anything we may have ever considered encountering. There'll be radioactive life forms. You could hardly imagine how they respire or what they do in their day or how they are, but they exist. They have the potential to exist. They very well could be out there. My name's Todd Gooch. I'm seeking a MacArthur Award. My theory is gravitational unit theory, unified field theory. Thank you very much for your time.